Very well. We are on example 4. What does it tell us? First of all, you have a figure on the right-hand side, shows the lengths of time people spend driving each day. You randomly select 50 drivers. What is the probability that the mean time they spend driving each day is between 24.7 and 25.5 minutes? Suppose the standard deviation of population is also given. So what are we looking for? We're looking for probability. What is the probability? First of all, let us take a look at this data that we have. Here you have 1, 2, 3, 4, and 5 values. How many drivers do you have? 50 drivers. Is the sample size greater than equals to 30? Can we use central limit theorem? Yes. Since the sample size is large enough, you're allowed to use the central limit theorem to find the mean and standard deviation of sampling distribution of the means. Remember the formula. Central limit theorem says mean of the sampling distribution of the means is the same as the mean of the population. The mean of the population is 25. Standard deviation of sampling distribution is standard deviation of population divided by square root of n. N, or sample size, is 50, and standard deviation of population is also given 1.5. So for this sampling distribution of the means, you have your mean and you have your standard deviation. This is not your population. This is a sampling distribution of the means. Perfect. We have two x values, 24.7 and 25.5. Our goal is to find the probability that x is between these two values. First of all, we have to convert x into z value. Our first x is 24.7. We already found the mean and standard deviation of this sampling distribution of the means. We know that z is equal to x minus mean divided by standard deviation. X is 24.7 minus the mean, which is 25, divided by the standard deviation. You can calculate standard deviation here and write it on the denominator. Your first z value is negative 1.41. Now, for the second x value, we have to transform this into z value. Z is equal to x minus mean divided by standard deviation. 25.5 minus 25 divided by standard deviation, which is 0.21 to 13. The second z value is 2.36. Now that we have our z values, we're allowed to use our calculator or z table. The probability that the mean is between 24.7 and 25.5 is the same as, is equivalent to finding the probability that z is between negative 1.41 and 2.36. So we converted x values into z values. This probability, this area, is the same as this area. Remember that when we are finding the probability between two values, we have to find each of those probabilities or areas and then subtract them. So the probability that z is less than 2.36 is almost 99%. The probability that z is less than negative 1.41 is almost 8%. If you do the subtraction, the probability is around 91%. How to interpret that? Of the samples of 50 drivers, ages 15 to 19, about 91% will have a mean driving time that is between 24.7 and 25.5 minutes. Next example. Example 5, find probabilities for sampling distributions. What do you have? You have the mean room and board expense per year at four-year colleges, which is $91.26. So you have your mean. You randomly select 9, what's given? N is given. 9 four-year colleges. What is the probability that the mean room and board is less than $9,400? So our goal is to find this probability. The mean is less than $9,400. Very well. Luckily for us, we have the standard deviation, which is 1,500. First of all, we have 9 as our sample size. In this question, here we're looking for if this is normally distributed or not. As you can see, the room and board expenses are normally distributed. So even though this is 9 less than 30 is not important. We can apply central limit theorem. Central limit theorem says the mean of sampling distribution of the means is equal to the mean of the population, which is given. But to find the standard deviation of this new sampling distribution, you have to do a little bit of algebra. Sigma sub x bar is equal to sigma population standard deviation divided by square root of, and sigma is given 1,500 divided by square root of n, which is 9. If you do the calculation, get 1,500 divided by 3, which is $500. Now that we have our mean and standard deviation, next step is to find z. We have to convert x into z. Our x is 9,400. 9,400 minus the mean, 91.26, divided by your standard deviation, which is approximately 0.55. The probability that the mean is less than 9,400 is the same as probability z is less than 0.55. By using your table or calculator, we can actually see it's about 71% probability of such sample, which we know that it has 9 data in it, will have a mean less than 9,400, and of course about 29% of these sample means will be greater than 9,400. Cool. Last example here. So finding probabilities for X and X bar. This example says the average credit card debt carried by undergraduates is normally distributed. Okay, good to know. With a mean of $31.73 and standard deviation of $11.20. So these information are given. First of all, what's the probability that a randomly selected undergraduate who is a credit card holder has a credit balance less than $2,700? Okay, perfect. Here we only have one person, just one. N is equal to 1. Very well. Let us convert X into Z, then use table or calculator to actually calculate the probability. Z is $2,700, Z is X minus mean. Mean is given, sigma is given, so 2,700 minus 3173 divided by sigma 1120 equal to negative 473 divided by 1120, which is negative 0.42. This is our Z value. To find the probability, we either use the table or calculator. Since it's less than on the left-hand side, the probability is 34%. So it's roughly 34% chance that randomly selected student has a credit card balance less than 2,700. 2. Now you select 25 students. What is the probability that their mean credit card balance is less than 2,700? N is equal to 25. So we have to use central limit theorem to find the standard deviation and the mean. So X stays the same. X is equal to $2,700. Z is equal to X bar minus the mean of the sampling distribution divided by standard deviation of sampling distribution. Your X bar, 2,700 minus mean, which is the same as the mean of the population, 3173, divided by standard deviation of your sampling distribution of the means is not the same as the standard deviation of population. You have to do a little bit of algebra. 1120 divided by square root of n, which is 25. After doing the algebra, your Z is equal to negative 2.11. Now we use our table or calculator to find the probability, which is equal to 0.0174, which is roughly 2%. So let's take a look at the interpretation. Although there is about 34% chance that an undergraduate, just one undergraduate, will have a balance less than $2,700, there is only about 2% chance that the mean of a sample of 25 undergraduates will have a balance less than $2,700. because there is only 2% chance the mean of a sample of 25 undergraduates will have a balance less than $2,700. This is an unusual event. Remember that when it comes to probability or area, if the probability or area is less than 5%, we say that it is unusual because it is near the tail.